Hi friends, my name is Narayana. Today we are going to discuss about data link layer. Data link layer is a layer to layer 2. We will discuss that the layers will take information from higher layers and transmit into the lower layers. For data link layer, the network layer is the and top layer. It will take data from network layer and transmit into the physical layer. The data link layer will convert the zeros and ones into the frames. They will have a frame structure is there. We are going to discuss it. First of all, we are understanding that what are the functionalities data link layer will perform. Our main goals of data link layer is to error detection and correction. Whatever the information we are sending from one end, it is receiving correctly at another end or not. It is used for error detection and correction, and sharing a broadcast channel and link layer addressing. The link layer addressing is that we are adding source MAC address and destination MAC address like that. So it is identified by each link. It's not from source to destination. It is identified by each link, and it is also responsible for data transfer and flow control. Flow control we already discussed that one end is transmitting at high speed, but another end is not capable to receive that much amount of speed. Then the sender will decrease the speed based on the receiver, and it will transmit. That is called flow control. Then these are the outlines of data link layer. This is the functionality of data link layer: error detection and correction, multiple access protocol, and LAN of ARP, address resolution protocol. To find out the destination MAC address, we will use ARP. Then there are different protocols we are used in data link. For example, Ethernet is one of the protocol. These are the devices of data link layer: hubs, bridges, and switches. These are the devices. Then PPP, these are the protocols, data link layer technologies to transmit one end to the another end. Here the important thing we are understand host and routers are nodes, and these are all nodes. These host and these routers are all nodes, communicating channels that connecting to the nodes along with the communication call is long. See, this is to communicate one node to the another node, we need a link. This is called link. These are the nodes, these are the computers, and routers. These are all nodes. See, and to communicate one node to another node, we need a link. This is the link. We need a link to communicate one node to another node. So this link we are using, for example, here we are using Ethernet technology, but here we are using maybe the ATM technology. From here to here we are using the PPP technology. Like that, we are using different protocols and different links based on their design. Who have designed the architecture, and they want to use based on their requirement. It will be different. So what we are come to a conclusion that it's not necessary to use the same protocol at every link. So the protocol in every link may be different. Here the link they may use for example, they may use Ethernet. From here to here they may use Wi-Fi. Wi-Fi also is data link layer technology. See, the data link layer main functionality has responsibility for transferring the datagram. Datagram means the amount of data it is carrying is from one node to the another node. It won't transfer from one end to the another end. For example, you are transmitting from this computer to this computer. It won't transfer from end to end. It is from one node to the another node. Okay, it is responsible for transferring datagram from one node to the adjacent node over a link. Over this link, it will responsible for transferring data from one node to the another node. Here it will design a frame structure. We will discuss in coming what is the frame, what is the header of the frame, and what is the frame structure. Here it will divide the data into the encapsulated data into the frames. It is what here it is discussed. Then the datagram transfer over different links protocols over a different links. Here different transfer over a different links, not only single link. In different links it will transfer. This is the example. Ethernet at first link, they may use Ethernet at first link, and frame relay at the intermediate. In between they may use, this is maybe the frame link, and 802.11, this is the Wi-Fi at the last link. They may use Wi-Fi at the last link. So it's not necessary to use the same technology at every link. The technology used at every link may be the different based on their requirement. They use different technology. Different at every link they use different technology. Here it is the thing. See, each link protocol provides a different services. See, Ethernet provides different services, and 802.11 provides their technology is different, but they mainly use it for data transfer, and the core responsibility will be the same, but their structure and header will be the different, that is each link provides different services. Okay, here this is the thing, this is the link layer services. It is divided into the frames and into the link. See, encapsulate the datagram into the frame. See, he received datagram from physical layer and it is encapsulated the datagram into the frame. Frame architecture is there, so it is arranged into the frame, and adding the header, it will add the header and tiler. Tiler is a CRC for error correction and error detection purpose mainly. So it will encapsulate the data he received from the physical layer. He encapsulated data into the frames. So each frame contains the source MAC address, destination MAC address. It will divide the data into the frames, and it is add the header, required header it will add, and it will add the tiler, and it will do see physical addresses means MAC addresses used in the frame header to identify the source and destination. So it will going to add the physical addresses, MAC addresses, to identify what is the source, and this is the IEEE number of MAC address is IEEE given a some particular number. This is a unique number. Each device, for example in mobile also IMEI is a unique number to identify the mobile. Like that in computer, in every computer, every system or a computer, they have a MAC address, unique MAC address to identify particular device, particular computer, different from IP address. The IP address is different, MAC address is different. For example, the IP address will change. For example, if you restart the computer or if you connect different networks, the IP address will be the change, but the MAC address is the same. The MAC address won't change. It is hard coded into your RAM memory, your computer RAM memory. It will hard coded and placed into here, so it won't change it. But the IP address will change whenever you restart or you are going to connect different systems. The IP address will be changed, but the MAC address won't be changed. This is the thing we are see for it is. This is the thing where it is used for error detection. We have a CRC is there in the header. By using that, if the CRC whatever we transmitted and received CRC both are same or not. If the transmitted CRC is not equal to the received CRC, there may be a error. That's why we are going to detect it. Error correction. We are adding some coded bits here to correct the error. Basically, the errors are two types: forward error correction and backward error correction. See, we will discuss here what is the forward error correction and backward error correction. See, the forward error correction is something like that. You transmitted data and you are adding some coding bits. Coding bits are some dummy bits we are adding. So it will increase the size of the data. For example, the data is a 200 bytes. You are adding another 200 bytes. It will total is a 400 bytes data. So if you added data and coded bits and transmitted, if the data is corrupted, by using these coded bits you are going to correct the data. I hope you understand. There is no retransmission is necessary for forward error correction. This is the forward error correction. Forward means it is going to forward, so it won't come into the backside. Backward error correction means it will send a negative acknowledgement. You are sending data and you are attaching CRC, cyclic redundancy check. The transmitted CRC is equivalent to the received CRC, then there is no error. If there is a difference between transmitted CRC and the received CRC, there is error. It will send a negative acknowledgement. Here you can send that backward. It will come back. Means it will send a ACK or NAC. ACK means successful, NAC means negative acknowledgement. So it will going to retransmit. That is the backward error correction. Forward error correction means it will go in forward only. So this forward error correction, it will correct the data by using the coded bits. This is the coded bits are there. By using that coded bits, it will going to correct the data. That is the two types of correction methods are there: forward error correction and backward error correction. Then we are going to discuss about more on see the frame structure. We are going to discuss what is the frame structure of see, this is the frame structure of Ethernet. The data link layer what we are going to discuss is the Ethernet. First we start Ethernet. Ethernet is famous one. Everyone is following Ethernet car. See, then the Ethernet header. See, we are already discussed that the data link layer what it will do is it will take the data from the physical layer and it will arranged into the frames. Then it will add the header. What are the header it is adding based on the protocol we are using in the data link layer. Here we are using the Ethernet is a protocol we are using, so it will add the Ethernet header. And Tyler is nothing but the CRC is the Tyler cyclic redundancy check. Here you can see that 7 bytes, it is totally 8 bytes. 7 bytes is the continuous 101010. The last byte will be the 11. First 7 bytes will be 10101010. The last byte will be the 101011 we are adding. The preamble will identify that start of the one frame and end of the one frame, where the frame is starting and where the frame is ending. Here the frames are continuous. For example, if you are sending some data, downloading some data, here you are using and downloading some YouTube. Here the data we are receiving from the Facebook is continuous. The data we are receiving from the Facebook is continuous. So they are dividing into the frames. See, they are dividing into the frames. They will add one frame to identify that which frame to differentiate the data. So here we are adding a preamble to indicate that start of the frame. Whenever the preamble you see, it is the start of the frame. Then this frame is ended. Then again we have a preamble. That preamble will indicate that is the second frame. That's why there are a lot of frames are there. They will identify the each frame by using this preamble. The preamble data is the fixed data. Here it is 8 bytes data, but 7 bytes. First 7 bytes are 101010. The last byte will be 101011. This is a 8 bytes data it is carrying. Then the destination MAC address. This MAC address will be the whatever where we are sending. Here we can send the one from one node to another node. What is the destination node? The destination node will be router. Either you are sending to the router or you are sending to the adjacent computer. This may be destination computer address or maybe the router address. Okay. So where you are sending the destination MAC address, it will contain the source MAC address from your computer. From your computer you are sending, so your computer MAC address will be source MAC address. From you are receiving from someone, the source MAC address is their MAC address. Okay, their MAC address it is saying. Type will tell you what kind of data it is carrying. It is IPv4 or IPv6. Actually, the Ethernet will carry the top layer data. For example, it is carrying network layer data. It is adding IPv4 or IPv6. It may have some. It may carry some other protocol. For example, ARP, address resolution protocol. The ARP protocol is used to find out the destination MAC address. So it is used to find out the destination MAC address. It may carry the ARP data also. What kind of data it is carrying? What kind of data it is carrying? That is represented here. Type. This type, for example, it is contain 1. Type 1, it will tell you that it is carrying IPv4. Type 2, it will tell you that it is carrying ARP data. Type 3, it will tell you that it is carrying RARP data. So why it is telling that? Why it's need to tell what kind of data it is carrying? See, if you know that what kind of data it is carrying, it will transmit corresponding upper layers. So it is carrying ARP data. It is the ARP header is the different. So it will transmit intimate that upper layer. Hey, it is ARP data. So it will remove the header, corresponding header, and it will do the functionalities. So every protocol header will be the changes. They don't have a fixed headers. See, the IP header is different, ARP header is different. Okay, the IP header size is different, and the ARP header size is different. So we are going to tell that it is ARP header. So it will read the ARP header like that. So it is all our layers are software designs. So in software design they write a code like for example, you are a software engineer, you are writing a code for Ethernet. You have to write first 7 bytes will be the preamble, whatever the data we are receiving. First byte 7 bytes are preamble, last byte total these are 8 bytes. First bytes are 101010, it will come like that. Then the last byte will be 101011, it will come like that. Then the destination MAC address you have to read, this is the 6 bytes. Then the source MAC address is the 6 bytes. The type is the 2 byte. Then the data is there. Then this CRC is there. The last 4 bytes are the CRC. You have to write a code like that. Then you have to read the data in the data link layer. You have to tell that what kind of data it is carrying. For example, if it is carrying IP data or ARP data, so this type will tell you what kind of data it is carrying. It is very necessary because it is need to transmit into the upper layers based on the type of data only. Here you have to. That is the thing. Then here it will tell you what is the use of this address is the 6 bytes. This address is the right. This is the 6 bytes. This will be the source MAC address, destination MAC address, source MAC address. This type will tell you indicate to the higher layer protocol, mostly IP, but most other cases may be served by such as maybe it is carrying some other data. You don't need to tell that it is completely IP. If it is only IP only, you don't need a type. Okay, if it is IP only, we need to write a program that the data it is carrying only IP only. You have to read the data and remove only the IP header only. Here the IP also different. It may carry IPv4 data or IPv6. Now we have two types of IPs, right? IPv4 and IPv6. We have to tell that. Then only it will go and remove the corresponding header. The CRC check at receiver. If error is detected, then the frame is simply dropped. Okay, it will drop the frame if there is error in the frame. Okay, that is here we have discussed it. Here then we are going to we discussed about what is CSMA CD. We will discuss in now we will discuss what is CSMA CD. This is the basic thing. Here you can put the frame structure here. Then we are going to discuss from here. Here we are going to discussing about data link layer. We already know that the different kinds of data link layer protocols are there: Ethernet, PPP, ATM, and FR and Wi-Fi. These are all. We are discussing about Ethernet. Here error detection only, error detection and correction. CRC, by using CRC we only detect the error. See, error detection is possible, not for error correction. It won't use it for error correction, the CRC. Then medium access control, MAC address. MAC layer is there, MAC address is there. Then we are using CSMA CD. What is CSMA CD? For example, your computer is there. This is your computer. This is another computer. They both are transmitting data to the. This is the cable to the, for example, switch or a router. Here you both are transmitting at the same time. You are transmitting at the same time. This computer also sending the data at the same time. So there may be a collision here, because they both are transmitting at the same time. There is a collision here. So your data is not transmitted. There is a collision. That is how can we detect there is a collision? Okay, there is a thing here. He feel that there is no collision. I am transmitting the data. He also feel that there is no collision, transmitting data. But there is a collision. There is a collision. If the collision happens, the data will be lost. Whatever the data he transmitted, that will be lost. So how can we avoid the collision here? By using CSMA CD technologies, who can avoid the collision. For example, you transmitted 1, it will plus 4 volts. You transmitted 0, no voltage. We already discussed that. There is a timer is there in the other side. If you are transmitting anything, zeros and ones, it will transmitting into the physical. It will calculate. For example, first 5 microseconds there is any 5 volt, any voltage is there, then it will note down as a 1. There is no voltage, it will note down as a 0. Like that it will calculate. If there is a collision, what happen is this one and this one will be combined. For example, see here, this one whatever here sending, this one will combine. The voltage will be increased. The future of the voltage is, if any two voltages are there, it will add the voltage. So the total voltage will be the 10. So the total voltage will be the 10. There will be a collision. So they both will know, hey man, there is a collision, because voltage is suddenly increased. The node will be 10. If there is one and only, there are two binary digits only. If there is any voltage is there, that is a plus 5 volts. There is no voltage, there is 0. But here 10 is there. If you found the 10, so there is a collision is there. Then they will identify that, hey man, there is a collision. Then what they will do is, they will pick up some random amount of time. The random time will be the different time. Here he may took 10 milliseconds. He may took 20 milliseconds. The random amount of time. I am telling you, not exact number, but they will take some random amount of time. They will wait that much amount of time. They won't send any data. Then they will send the data. If they again collision, they will again took a random amount of time. Then they won't send any data, and they will send. This random time will be the different. See, he is taking 10 milliseconds. He is taking 20 milliseconds. They won't take a same random time. So what is the problem if they took same random time? If he took 10 milliseconds, he may took the same 10 milliseconds. Again collision. So the random time will be the different, and they will going to transmit. And if there is again collision, the voltage will be increased. Then they come back, and again they will do the retransmission. That is the thing. That's why we are identifying that whether there is a collision occurred or not. This is the case. See, any device first verify if the channel is free or not before transmission. It will verify any data is going or not. If the data is going on, there is a voltage in here, so it won't send the data. So collision can be detected by the device with the help of the voltage changes. Here the voltage will be increased into double. That is the case. So abort the collided transmitted immediately. If they found there is a collision, it will abort, means cancel the sending the data, stop sending the data. There is no use by sending the data because there is a collision happens. so it will stop sending the data. All the devices encountered a collision, so they found that there is a collision here. There are these two devices. For example, there may be another device also. For example, some another computer is there, he is also sending the same data. Some another computer also, he is also sending the same data. So they stop sending the data. They found that there is a collision here. Okay, they all are aborted sending the data, and they pick up a random moment of time. See here, this is the, they are going to pick up a random moment of time. They won't pick up the same time, they will pick up the different time. Okay, retransmit the frame by applying random time plus rule 1. Rule 1 is first verify there is a transmitter any data going or not, then they will retransmit by applying retransmit the frame by applying the random time. They will pick up a random time, they will took a random time, and they will transmit the information. That's why they are going to do. Here we can see that every computer will have an adapter called a NIC card. So every computer having some NIC cards we have installed in every computer. This is also called as Ethernet cards and LAN cards. We may call it any name, but they all are going to say the same thing. There is called a NIC card or Ethernet card in every PC. Like that, we have a WIC card, WAN interface card in a router, but NIC card is present in every computer. In Linux OS, we can find out by using the command ifconfig. See here, there are two NIC cards are there in my computer. Here ENPC S0 and WLAN. This is the NIC card. This is my MAC address, computer MAC address. Then this is the IP address. Okay, this is the IP address, this is the MAC address. See, this is the another MAC address. See, this is the another MAC address. See, based on the NIC card, the MAC address will be the different, because there are two NIC cards are there. That's why two MAC addresses are there. If there are more NIC cards, there will be more MAC addresses. That's why he is going to discuss about. See here, what is IP and above layers normally are part of operating system. The IP layers, there are 7 layers are there. The above IP layers and all are operating system. Operating system will responsible for that. Allocating IP addresses, all things, port numbers, allocating port numbers and layer 4 and all are IP address. But data link layer implemented in the adapters. See here, adapter is there, right? Here it is, for example, it is generating a frame, so it is going to check the in adapter what is the MAC address, so it will add in source MAC address. This is the MAC address it is going to add. This is the data link layer. It is responsible for adapter. Every Ethernet LAN card will have a fixed MAC address. See, this is a fixed MAC address. Once you buy a computer, it is hard coded into your computer RAM memory. Okay, it is not going to change anything. It is fixed information. It won't going to change information. That is all. It is a fixed MAC address assigned in the read only memory in your computer. This MAC address is 48 bits and should be unique. Okay, it won't be two computers won't contain the same MAC address. Okay, one computer will contain the unique MAC address. Who given this MAC address? IEEE administrator will give this unique implementation. Okay, OS and NIC cards communicate with each other using the LAN drivers. By using there are LAN drivers in your computer. So they will, the both IP layer and Ethernet layer, they will communicate with each other, because the Ethernet layer, what is IP address? How can he know? He know go to IP layer, he going to get it like that. IP, how can he know MAC address? He going to data link layer and he going to get it. So by using the LAN drivers, they will communicate each other. That is what he is saying. By using LAN drivers are there. By using the LAN drivers, they are going to communicate. Example of MAC address, you can see here. This is the MAC address. It is in hexadecimal format. There are different formats are there. Binary decimal formats 0 to 9, 0, 1, 2, 3, 4, 5. Those are the decimal formats what we are using. Binary format, zeros and ones are called binary formats. These are hexadecimal format 1 to F, 0 to F, A, B, C, D, F also there. After 10 is A, 11 is the B, like that. Up to 15 we are having hexadecimal format. So it is in hexadecimal format. If you convert in binary format, this is the MAC address of every company. This is the huge size, so the representation will be the difficult. That's why we are using a hexadecimal format. This is for just for understanding purpose, visible purpose, and saving purpose. No more like that. If you represent this way, it will take a huge size, and the representation also very difficult to remember. But this representation will be the easy way. That's why we are going for hexadecimal representation. See the framing, how they are dividing into the frames we are discussing here. The Ethernet attach a preamble. We understand that what is use of preamble. It will differentiate the frame. The starting of the frame will be indicated by preamble. The preamble, when you read the preamble, it will tell you that, hey man, the frame will start here, and CRC will tell you that the frame will end here. Then again there will be a preamble. It will tell that the frame is starting here. It is 8 bytes information. First 7 bytes are same. The last byte will be the 1 1 instead of 1 0. Then the frame ending. Frame sending, how the frame is sended. To send a frame, source MAC address is necessary. Okay, it will attach the source MAC address. For example, my computer source MAC address is this one. So what is the destination MAC address? You don't know the destination MAC address. Okay, how can you find destination MAC address? You will send some information from your computer to your friend computer. You know your source MAC address. Your computer is generating frame because he already know the source MAC address. But send a destination MAC address, how can he know? By using that purpose we are using a ARP, address resolution protocol. This is the very important one. By using this ARP we are going to find out the destination MAC address. How can you find out? We will discuss it. But this is the frame structure. It is having 8 bytes of frame, 8 bytes of preamble. Then the destination MAC address is 6 bytes. Source MAC address is the 6 bytes. Then the type will the 2 bytes. Then data is there. This data will be IPv4 data or IPv6 data or ARP data. This CRC, the 4 bytes. It will tell you error is occurred in the system or not. Then the header is total is 22 bytes. Then the footer is the 4 bytes. The total is the 26 bytes of additional information. Header we are adding. Okay, the total is the 26 bytes. He is telling that. Then many protocols can be used to service away Ethernet as a frame, and the corresponding type field should be used. See, for example, IP is a 0800. We use this type will tell you what kind of data it is carrying. For example, the type will be loaded in 080 0x0800. This is hexadecimal format. This is the decimal format 2048. It will tell you that the data is the data it is carrying IP data. Okay, then this type will tell you like that. It will he is going to tell that it will provide different services. For example, ARP data you want to send it, you can mention a type. If this is ARP data, then the ARP data will going to send like that. Ethernet can pump different kind of protocols. He is saying that. Then how can you find out destination MAC address? This is the important. How can you find the destination MAC address? By using ARP, address resolution protocol, you are going to find out. Here what you are going to understand is, see, every system can have multiple NIC cards. See, my computer having 2 NIC cards. See, this is the NIC card 1, this is the NIC card 2. Like that, every system having a multiple, not only 2. Some high advanced systems may be having 4 to 5 NIC cards. So if they are generating IP packet, they will generate the IP packet from any NIC card. They will generating from this NIC card, and by making source MAC address is this one and destination MAC address, and they are going to find out the destination MAC address. Like that, every computer having multiple NIC cards. For each NIC card there should be at least one IP address is assigned. So in each NIC card there will be one IP address. This is the IP address of NIC card. Like that, different NIC cards having different IP address. An IP packet is manufactured by the network layer with source IP and destination IP. So the IP packets, we understand that in IP header they are having a source IP address and destination MAC address, but they are having a source, 2 IP addresses necessary, source MAC address and destination MAC address. See, in ERP, how can they find out the destination MAC address is? For example, here you can see he is sending the data from here to here. He know that this is the source MAC address, and the destination MAC address he don't know. How can you find out this? By using the ARP, address resolution protocol. He can find out that. See, how can you find out this? He is having there is a ARP header is there. In the ARP header he having a destination MAC address, source MAC address, and type will tell you this 0800. It will be the data of IP packet. Then CRC, then he what we are going to do is, at first time we don't know the destination MAC address, he will put FFF. This is the broadcast address. He is going to every node and he is sending. Then the source MAC address he will add. Then the type is 0806 ARP query. It will perform ARP query and ARP response. 2 types are there, request and response are there. At the starting time you don't know the destination MAC address. What he will do is, this computer, for example, this computer is sending ARP query. He don't know the destination MAC address. This MAC address he want to send it. This don't know. He know the destination IP address. You know where you want to send it. So he will send a ARP query. I want a destination MAC address, but IP address is this one. I know the IP address. but I want a destination MAC address. He sent to everyone. He sent to every link. He sent link here. It will broadcast the every link. Whatever it is connected, it will broadcast it. Then the person who is having that destination IP address, he will respond it. That is called ARP response. In ARP response, it will indicate that this is my MAC address. He will indicate destination MAC address by using ARP response. Okay. In ARP query, ARP it will broadcast it. ARP query will broadcast the information. He know the destination he know the destination IP address. He know the destination IP address. It is going to broadcast the information. Who is having the destination IP address, they will reply that. ARP response. In ARP response, the person who is having destination IP address, he will reply with MAC address. Like that, he will reply. He will broadcast into every node. ARP request is always broadcast. ARP reply is unique cache. Who is having that destination IP address, he will reply that hey man, this is my MAC address. So he will generate a frame by arranging source MAC, destination MAC address. Then it will transmit. You know the destination MAC address now. Then he will generate a frame by preamble, destination MAC address, source MAC address, and he is going to send that information. Like that, he is going to use it. Here you can see that you can generate a frame, then we send it. See, for example, now here you are using here ARP request. Here he is querying who has 192.168.0.1. he is asking that he is no the IP address. This is the destination IP address. Here you can see the frame structure Ethernet. See, this is the ARP header. This is the IP address. You know the destination. This is the destination. This is the source MAC address. Okay, he is querying that. He is querying who is having target MAC address. You don't know the target MAC address. He is querying that. He is a source MAC address. He is no source MAC address, source IP address, but he don't know the destination MAC address. But he knows the destination IP address. By using destination IP address, he is querying who is having this information. See, it is a broadcasting information. He is broadcast that information by placing FFFF is the broadcast information. You don't know that he broadcast into every node. So who is having that one, he will reply that. See, here it is broadcasting to find out the destination MAC address. Then the person who is having that destination, he will going to reply. See, it is going to reply by using that MAC address. By placing the MAC address, it is the MAC address of that particular system. That cases we are using ARP. This is the Ethernet structure. Here preamble is not there, but preamble must be there to find out frame. This is the frame structure. This is the frame number. Every frame starting with one number, they will have a number is there. This is tell you how much data it is carrying. This is actually, this tool is a Wireshark tool. It will map into your Ethernet NIC cards, and it will capture whatever the information is transmitted and sending, and it will arrange you in a manner you can understanding it. This is ARP header. ARP header contain hardware tab. This is the hardware is the Ethernet we are using. Then type what IPv4 is the protocol type. Then the hardware size is 6. Then protocol size is 4. In the opcode, it is a request or reply. It is a reply. For example, this broadcast is a request. Then the reply will come. It will come as a reply. This is the reply. Then the sender MAC address. The person who is sending that MAC address is this one. Then the sender IP address. Then the target MAC address. Then the target IP address. The reply will contain the MAC address. The request broadcasting, it won't contain, because we are going to find out, we are broadcasting this information. We know the IP address, we want a MAC address. Here this is the MAC address, this is the destination MAC address, this is the destination IP address. So for him, for the destination, for us, we are the destination for the sender, like that. Then we have devices are there in Ethernet layer 2 devices. The repeaters, hubs and bridge, these are all, and switches, these are all data link layer devices. They won't understand IP packets, they can understand only frames only. What is a repeater is, repeater having two interfaces. Repeater will amplify the signal strength and send it. It is a bit by bit processing. It is having two interfaces. For example, this is a repeater. It is having two interfaces. Whatever the data is coming from here, it will amplify the signal and it will send to another side. So it is like that it will perform. It is a pure physical layer. It won't understand IP packets. It will amplify the signal. The hub is similar like a repeater. It will amplify the signal, but it is having multiple interfaces. So it will transmit. It will receive the data from one interface and broadcast that information into all interfaces. For example, in this hub, it is having 4 interfaces. It will receive the information from one interface and it will transmitting into the all interfaces and amplify the signal and sending into the all interfaces. Where we can use this repeater and hubs is, if you want to transmit the signal from long distance, if the signal strength is decreases, you have to increase the signal strength. We need a repeater and hubs to increase the signal strength and send it into the long distance. That cases we use hubs and bridges and switches. This is also a data link layer. It is handling physical layer implementation as well. The thing is, it is containing a buffer, so it will store and forward. If any computer having any device having buffer, it can store the information and transmit. That is the use of the buffer. And it is detect the frame starting and ending by using preamble. The bridge will detect the information and send it. That is a bridge will do. Bridge, how can he find out the information is, first of all, he receive the information from one end, then first time the bridge will act like a hub only. It will transmitting into the every node. For example, 3 interfaces it is having. He don't know the destination MAC address. It will transmit the information into every node. Then he receive the information. Then in his database it will add the MAC address and the interface. Which, for example, this interface is F0. This interface is F1. This interface is F2. Then it will add the interface and MAC address as a combination. Then any next frame is there, then it won't transmit into the every frame, every node. It will identify that where to transmit. So it is maintaining the bridge will maintain a table where to transmit. At starting it will act like a bridge only. It transmitting into the every node. Then the reply will come back. The reply will come back. It is noting into that MAC address. So if any frame is there, so the next time onwards he transmitting into the correct manner. So the bridge will learn from himself. That's why we call bridge as a plug and play device. Here you can get it. The bridge. That's why we are calling it as a plug and play device. He learned by himself. He learned the MAC address by himself. That is, he is also performing CDMA, CSMA CD technologies, because first it will check that whether any data is going or not. If there is no data going only, it will send that. If there is a collision occurred, it will perform CSMA CD and it will wait some time and it will transmit it. That is the main thing it will perform by bridge. Then we are going to discuss in bridge how can it perform. See, the index bridge table with the MAC address and primary key. See, frame received. If any frame is received, bridge verifies the source MAC and its interface combination. See, for example, the frame received in bridge, it will verify which interface it is receiving and what is the MAC address it is receiving. So first it will verify in the table. In the table, this MAC address is present or not. If the table doesn't contain this MAC address, the received MAC address, then it will add that MAC address into the table. It will add MAC address and interface, which interface he received. This interface combination it will add, and it will transmitting into the every node. It's starting. Then the reply will come back. That MAC address and that interface it will add into this table. See, bridge check destination MAC address in the bridge table available or not. If not available, forward into all interfaces. If available, then it is add the entry pointing to the source interface. Drop the frame. Else forward into the pointed interface. Okay, it will drop into that particular interface. If you know the destination MAC address, that's why it is doing, and it is applying CSMA CD before forwarding the interface. See, if there is already information is going on, if you transmit that again some another interface, there will be collision. That's why we are performing CSMA CD before transmitting the information. Then we have a switches. switch all the information, all the functionalities the bridge will perform, the switch also perform the same functionalities. Whatever the bridge will perform, the switch also perform the same functionalities. It will know the MAC address by himself and it will transmit the information. But what is the additional functionality the switch will perform is, switch is having multiple interfaces. It will transmit the data at it will it will forward the data of all the interfaces at the same time, not at the one interface at a time. For example, this is the switch is there, it will transmit the data of interface 1, interface 2, interface 3. For example, these three interfaces transmitting data at the same time, the switch having a buffer, it will store the data and process the data at the same time. The bridge won't process the data at the same time. The bridge processes the data one data at one time only, but switch processes the data at all time. The switch won't understand IP packets, it will understand only the frame packets, Ethernet packets only. The frame architecture it will understand, it will identify that it is also performing CSMA CD, and it will, before transmitting the data, it will verify that whether the link is free or not. If the link is not free, it will store and forward it. The advantage of switch is there is no collisions in the switch. It will make sure that there will be no collisions in the switch. For example, this is the router. The router having switches are there. These are the two switches on router. In each switch there is two computers are connected on every switch. So they are going to send a data. They are going to send a data. While sending the data, the switch will perform CSMA CD. There is no, make sure that there is no data is going on. Then it will perform the data, and he is having some intelligence to know where to send a packets and which interface he need to send a packets. So there is no collision happens in the switch. Please make sure that there will be no collisions in the switch. It is performing cut through switching. This is the basic understanding of data link layer. Here you can see the structure of header, structure of Ethernet here. Ethernet header, it is containing preamble not shown here, but it is containing destination MAC address. This is the source MAC address, and the type will tell you it is carrying ARP data. That's why the type is 0806. This type will tell you this is the 2 bytes data type is. Here you can see this is the type is the 2 bytes. Then ARP header, it is tell you the hardware type is Ethernet cable is there. That's why the type is Ethernet. The protocol is IPv4. This is the hardware size, the protocol size, opcode. This is if it is a request, if it is a request, and reply, it will be a reply. For example, this is the reply. It is containing the reply here. Then the source MAC address, destination sender IP address, then target MAC address, target IP address. For example, if you want to see general if it is containing IP packets or not, here you can see here the type will be 0800 because it is carrying the IP. Based on the type, the application will be changed. For example, if you carrying IP, the type will be the 0800. So it is carrying IP header. Then the receiver will know that this is IP. So they will calculate as a IP header. This is the IP header. They will calculate like that. Then the next class we are going to discuss about the IP header, the IP layer. This is for Ethernet header and Ethernet. What is the advantage of Ethernet? Then we are going to discuss about the IP layer. What is the advantage of IP header and IPv4? We are going to discuss it. How can we manufacture the IP packet and send it? Total we think we discussed about it. We are maintaining in Facebook page Welcome Learning. Thank you everyone.